Hello, today I'll be solving problem number 78 in section 10.3, and first I'll need to find the unit vectors tangent to each curve at each point of intersection, and I already have this graphed out for you. So first we're going to have to find the derivative to find the slope of each vector tangent, and to do that we are given the equations y1 equals x squared and y2 equals x to the 1/3, so y prime of 1 should equal 2x, and y prime of 2 equals 1/3 x to the negative 2/3, or 1/3x to the 2/3. And so from there we're going to plug in the points of intersections that we found just from graphing it to find the slope at each of these points, and from there we'll calculate the unit vector. So at 0, y prime of 0, 1, equals 2 times 0. That equals 0. And then y prime 1 of 1 equals 2 times 1 equals 2. Now for the second equation, y2 prime of 0 equals 1/3 times 1 equals 1/3. Y prime 2 of 1 equals 1/3 times 1 also equals 1/3. And so from here we can make the unit vectors by using these slopes to make triangles in a way. So for this one, if the slope is 0, it's a rise of 0 over 1. Let's just say it's over 1. So this will look like 1, 0. For this one, it'll look like 1, 2, rise of 2, run of 1. For these two, they'll both be the same. It'll be 1, 3. No, excuse me, it'll be 3, 1. Rise of 1, run of 3 is 1/3. 3, 1. Cool. So now we have to calculate the unit vectors from these. And to do that, we simply make these triangles, calculate the hypotenuse, and then divide each component part by the hypotenuse. So for this first one, it's easy, because we have 1 and 0, so it's 1 squared plus 0 squared, and that obviously just equals 1. So 1 over 1 and 0 over 1. The unit vector of this first one will be 1, 0. The second one, 1, 2, 1 squared plus 2 squared, that equals radical 5. So we have 1 over radical 5, 2 over radical 5. That's our second unit vector. Cool. Now to the next one, and they'll both be the same because they have the same components. So it'll be 3 squared plus 1 squared, which equals radical 10, and then it will be 3 over radical 10, 1 over radical 10. Cool. So now that we have these, we can go and calculate the angle between them using the formula cosine theta equals u dot v over u magnitude of u times the magnitude of v. And because we already have the unit vectors, this is just going to be 1 anyway. So we're really just interested in the dot product of u times v, and I'll do that over here. So with our first vector, we're multiplying 1, 0, which is the unit vector of the x squared equation, times 3 over radical 10, 1 over radical 10. So to do the dot product, we just multiply each term and then add them up. So it's 1 times 3 over radical 10, and then 0 times anything is 0. So we're left with 3 over radical 10. And if we do cosine of theta equals 3 over radical 10, theta equals 18.435 degrees. I already did that beforehand. I'm not magic. Now if we move on to the next one, we have 1 over radical 5 and 2 over radical 5 dot 3 over radical 10, 1 over radical 10. So we'll do that. 1 over radical 5 times 3 over radical 10 plus 2 over radical 5 plus 2 over radical 5 times 1 over radical 10. And so we'll just multiply everything. So we have 3 over radical 50. So you can just multiply these two things together, plus 2 over radical 50. So which simplifies to 5 over radical 50. Cosine of theta equals 5 over radical 50. Theta equals 45 degrees. Cool. So to summarize, to answer those first questions, the unit vector for each point, for each graph, is as follows. 1, 0, for the x squared graph at 0. For the x squared graph at 1, it is 1 over radical 5, 2 over radical 5, and then for the x to the 1/3 at 0, that is 3 over radical 10, 1 over radical 10, and x to the 1/3 at 1 is also 3 over radical 10, 1 over radical 10. And the angle between these two, 18.435 degrees. Angle between these two is 45 degrees. Well, I hope this helped. Boom!